Hello everyone, welcome to the SouJava channel. So my name is Maximilian. Let me switch to Portuguese because our audience also understand Portuguese one. So let me switch to this, ok? Muito bem, boa tarde pessoal aqui no Brasil, pessoal que está aí no mundo inteiro. Meu nome é Maximilian, estou aqui no canal do SouJava. Bem-vindo a mais um SouJava Talks. Hoje nós vamos trazer aqui a Alina, que vai falar sobre GraalVM, e vai ser muito interessante aí assistir a palestra dela. Se vocês estiverem travando aí minha tela, desculpa aí, mas eu estou passando por problemas técnicos. Vou mudar para inglês aquela de volta, ok? Okay, everyone. So today I'm bringing to you an amazing developer advocate from Oracle. It's Alina Yurenko. So sorry for any kind of problem that I'm facing. Actually, I'm facing technical problems. Who didn't face this kind of problem? Okay, but I will bring Alina and then I will let her introduce herself. Okay, so Alina, I will bring you. Okay, I will turn on my camera because my camera is working. My transmission. Hold on. Hi, Alina. How are you?
Hey, I'm good. I hope you can hear me. You can see me. Are we all good?
Yeah, I think so. Guys, say something in the chat telling us if everything is working so good and so on. So telling us where are you watching us? So where are you from? It will be nice to see that. Also, I talked a little bit with Alina, but if you want to ask something, just type on the chat. I will bring those things to Alina. If you want to question in Portuguese, don't worry, I can try to translate to in English. I'm not a professional translator, but I can try it. That's okay. So, Alina, if you want to get started, I don't know if you want to say something to the people. I don't know. I think I can't see right now the audience chat because my machine doesn't work. But I will share your screen and then get your start, okay? And get started. That's okay?
Yeah, excellent. Thank you. I'm also trying to access the chat from my phone and I cannot. I don't know, maybe there is nothing in the chat yet, but yeah, I cannot see it either. But please, people, if you are in the stream, react somehow to us so we can see that you are here too.
Okay, so I will be on the backstage and do your show, Lena.
Thanks so much. Thank you. Okay, is my screen on yet? I guess there is some delay.
Yeah, it is. Yeah.
Okay, excellent. Yeah, sorry for that. I'm just trying to coordinate how it's looking on YouTube, and I don't see it yet because I guess that there's a delay, but I think it should be fine. So yeah, hi everyone. My name is Alina. I'm a developer advocate for GraalVM at Oracle Labs, and I'm here to talk with you about Java in the cloud with GraalVM. One request that I do have to you though is that it's kind of challenging for speakers to do virtual meetups because we don't see the audience, we don't see people reacting. So if during the talk you could react in chat with, I don't know, emojis or comments, it will be very helpful because not seeing people in the room, it makes speaking very challenging. So if you could share some reaction, I would really appreciate it. So let's start the talk. And a few things about myself. So my name is Alina. This is my Twitter handle. So if you have any kind of question that you maybe don't want to ask publicly, you can also drop me a DM on Twitter and I will be happy to answer your question. I'm also a developer advocate for GraalVM at Oracle Labs. And Oracle Labs is this very cool unit at Oracle where we're doing a lot of research and a lot of our projects, and GraalVM included, come out of that research that we have been doing for years. I also love open source and communities. So for me, it's always a great pleasure to speak at some community meetup. And I love both programming and natural languages, and I'm also Ukrainian. So this beautiful city that you can see on my slides, that is my gorgeous hometown, Lviv. So if you ever have a chance to visit one city in Ukraine, I recommend that it will be Lviv. It's gorgeous, and I'm sure you will like it as well. So let me just take 1 second to readjust my setup so that I can hopefully see the chat too. Okay, hopefully this should work. And yeah, let's move on. So GraalVM, if you've been following GraalVM or if you've been checking it out, it could be your impression that it's kind of a Swiss knife, and it kind of fits because our HQ is in Switzerland, but also it's a bit confusing because there are so many things that you can do with GraalVM that sometimes people get confused when they can use it and what is the best component to use for their app and how exactly to configure it to work with your apps. That's why in this talk today, we will talk about one specific topic, and that is Java applications in the cloud and how GraalVM Native Image can help you build such applications. And one important distinction that I want to make here is to kind of remind you that there are a few ways to run Java applications on GraalVM. So one point is that overall GraalVM is also a normal full-blown JDK. So here on the left, you can see this JIT mode and how you can run your applications on GraalVM as you would on any other normal JVM. So let's say if currently you are running on OpenJDK or any other JDK distribution of your choice, the exact same way you can run the applications on GraalVM as JIT, and there is no migration efforts necessary from your side. You just replace that JDK distribution with GraalVM, and your apps would run as is on the JVM. But in this talk today, we will talk about this second mode on the right here, and that is the ahead of time compilation mode, and that is the native image part of GraalVM, which produces native versions of your Java applications. And those are really great for cloud deployments, and we will talk about why they're so great for cloud deployments in a second. And one more thing to know about GraalVM, and this is something very important also for me personally, is that GraalVM is a huge open source project as well. Our development is happening on GitHub, so if you're curious, you can see how we work on the project, what are the pull requests we are working on, what are the issues, the discussions we are having there. And somebody even told me, I don't know how to validate that GraalVM is probably one of the biggest open source Java projects. So if you're a Java developer, I think it's a very interesting project to look under the hood and see how something quite low level, such as compiler, is being developed in Java. So if you're a Java developer, and I assume you are since you're here, I encourage you to check it out. It's really very interesting. Okay, and now let's talk about Java in the cloud and how GraalVM can help you build such Java applications in the cloud. So one of the things that you probably want to achieve when you deploy your Java applications to the cloud is to start fast, so have this very quick startup time. And there are multiple reasons to do so. One is because your application would, start fast, so it would use fewer resources, but also in terms of what your users experience, so making this application available faster, sooner to your users is also a preferable way to run such app. So you want your application to start fast. Another thing, which is maybe even more important in the cloud, is you want to use as little resources as possible. So if you can have a version of your application that is doing the exact same thing, but at the same time it's using fewer resources, so less CPU, less memory, that will be, again, preferable in the cloud because those things contribute to your cloud deployment costs. So if you can get the same work done using fewer resources, that will be much preferred in the cloud. And in the cloud, as basically in any other environment, one more thing you probably want to do is to make sure that your application is secure and minimize possible vulnerabilities. And there is a very interesting aspect in how native image enables that as well. And we will talk about that later on in the presentation. And last but not least, you could be also looking at minimizing the packaging size of your application, because smaller apps mean smaller deployments, or if you are running in a resources constrained environments, this could be another important thing for you. So overall, this could be your goals for Java applications in the cloud, and that is exactly the things that native image can give you. So now let's talk about each of those in particular. So the first thing is startup time. And here, let's compare running app on the JVM and in native image mode. But first, I want to talk with you a bit about the context, so how native image builds your application, so you can see the differences between this running on native image and running on Hotspot VM. So the idea of native image and building your Java application as a native executable is to move all the expensive operations, so all the operations that take a lot of time and a lot of resources, move all of those to the image build step rather than application like running step, because most applications are started more often than they are built. So you can build your application once and then run it fast as many times as needed because you've done all this expensive overhead work at the image build step. So the idea is that we are moving all those expensive startup operations to the image build step. And how this is working in practice is that when you build your application, so when you run native image command and give it your Java application, what it will do, it will try to analyze your whole application under a closed world assumption. So everything there is to know about your app needs to be known at the image build time. So it will analyze your entire app at the image build time, starting with its main entry point, and it will try to find all the reachable code. So all the code that is needed for your application to perform and do exactly what it has to do, that all needs to be discovered at the image build step. So that is one thing. So we will try to find all the code that is necessary for your application to perform. And also we will eliminate everything that your app is not using so that this final produced native executable is as slim and lightweight and fast as possible. So we will try to find all the reachable code and compile it ahead of time. And another thing it will do, it will also initialize the application at the image build time so that it can come with pre-populated heap. So when you start your application, it is ahead of time compiled. So the machine code is already in there, but also it contains this pre-populated heap. So again, it can start faster because this already has been done at the image build time. So this is theory. And to compare how this compares with running your applications on the JVM, how you normally run your app. So these are the steps that need to be performed when you first run your application on a JVM. By JVM here, I mean, again, GraalVM JIT, OpenJDK, whatever is the JDK of your choice. This might as well be GraalVM only in JIT mode. So when you start your application on a JVM, what needs to happen is a lot of work. You need to load the JVM executable itself. You need to load jars, start interpreting, and interpreting in the beginning, it is quite slow. And as you're doing so, you will also start profiling, compiling, and then after all this kind of warm-up work has been done, you can execute at peak performance, but your application is already warmed up and compiled, and it can execute with the best possible peak throughput. So all those things need to happen when your application starts. Now, with native image, we want to move as much of this work as possible to the image build step. And since all of that is done at the image build step, when you start the application and it actually runs, what needs to happen and what you need the time for is to load executable itself. And then immediately you can start executing with optimized compiled code because we did all that work at the image start time. Okay, so this was a lot of theory. Let's see some demo application. And okay, my screen is smaller now, but I wanted to say that if at some point you get bored with my presentation, you can observe some trains behind me on this behind screen. Okay, and I can finally see some chat here in my StreamYard setup. Awesome. But let me show you this app and let me just pull the right window. Okay, what is happening? Yeah, this one. So what I have here is a pretty simple Spring Boot application. And here I have my main class and I have my controller. And for the sake of saving us all some time, I already compiled it to native. So when I check in my target directory for the files, I see my demo file that is executable. And when I run it, so demo, it starts. And it starts, I would say, pretty fast. So it's probably warmed up a bit because I tried it a couple of times before the presentation. But also I have a lot of streaming setup running on my local machine. This is also running locally. So I would say this is an amazing startup time for such an app. But also let's go and check it out. And I think it should be running at 80. Yeah, that is correct. So let's go here and let's go to 8080, and this is my app. So this is a pretty standard web server. As you can see, it's working perfectly fine, and it's very fast and very lightweight because it's compiled as native executable. And an interesting observation that I wanted to share with you as I was preparing this demo this morning. So when you go to start.sprint.io, as you normally would when you start a new project, and you want to add a new dependency, GraalVM native support is apparently the first thing you see in the dependency list. So it's very easy to build such app from scratch. You would just go to the start.sprint.io and start developing from here, and native image comes out of the box in the GA release as of recently. So yeah, this is how you would build such an app, pretty easy. And I think we will be waiting for some more cool announcements about Spring and GraalVM support in Spring, specifically in the Spring 1 conference, which is happening pretty sure this week. So let me know in the chat, how do you like those native Spring apps? And let's go back to the presentation. So here we were talking about starting an application and how faster native image is comparing to running on JVM. So this was the startup time, right? The first part of our Java in the cloud goals, or the benefits that we want to achieve there. But let's also talk about resources usage. So one of the things specifically that you care about in the cloud is memory, because this one is still quite pricey. And if you compare memory that is being used by the same Java application when running on JIT versus running in native image mode, we will see the following. So in JIT, obviously you would need the memory for the runtime itself, but also then for the things that are specific to your application and the code execution infrastructure, such as profiling, compilation data structures, etc. So this is all the memory that you would need in the JIT mode. And in the native image mode, you would need, again, some memory for those runtime components. But then again, for the application itself, you would only need memory around for application payload. And if you want to scale such applications, so if you want to add more instances of the same app and scale it this way, you would need, like, some things will be shared among processes in both JIT and native image mode. But then if you scale your application by adding more instances on the JVM, you would need to scale all those kind of code infrastructure components as well if you're running on a JVM. And then if you're running on native image, you would only need to scale memory for the application payload. So it's way more efficient because those runtime components will be shared in native image, and the only thing you would need to scale is the application payload and memory that it's using. And to illustrate this thought even further with some more practical example, here we are trying to scale an Apache Tika app by adding, again, more instances of the same app, and the red bars, that is native image, and the yellow ones, that is running on a JVM. And if we are adding more instances of this app with the JVM mode, we can see how we always would need more time, which is, I think, more memory, sorry, which is, I think, is expected, right? But if we are scaling the native image one by adding more instances, you would need a bit more memory over time, but it's uncomparable of how less memory that is, right? Because native image applications, since they are normal native applications, they would share machine code among themselves, but also they would share image heap. So you can scale such applications way more efficiently in terms of memory if you're running on the native image mode. And in terms of building such native image applications, my recommendation is that obviously you can always build something from scratch, but many of the Java microservice frameworks has adopted GraalVM and specifically native image as a platform to run Java applications. So if you want to get a lot of features and a lot of support out of the box, my recommendation is that you start with one of those frameworks. It's up to you which one to choose, but this will significantly simplify and help you build such apps faster, but giving you a lot of features, configurations, and help out of the box. Okay, and another interesting angle of native image that I think is not talked about enough is the security angle. So if you ever followed GraalVM or GraalVM native image, I think you heard all those things about fast startup, low memory usage, how fast and lightweight those native executables are. But I think the security angle is also very interesting, and we see more and more interest in GraalVM in this specific area. And let me tell you what is the security kind of perspective of running on native image. So the first thing is that known unknown code can be loaded at runtime, meaning that everything that native image will include in your produced native executable needs to be known at the image build time. So when the application actually runs, there is no possibility to run new code. And it is safer in this way because everything that you need for your application to run has to be known at the image build time. So you cannot, and no one can execute on your application some random code at the image runtime. So you have more control over this with native image. And also only the code that is reachable, so only the code that is actually being used for your application will end up in this final produced native executable. So if you have, I don't know, a bigger project, or if you are pulling some dependency that you maybe don't trust so much and you're not so sure about, native image will eliminate all the application parts that are not used effectively. So if there is something in your app that is never executed, native image will not include it in the produced native executable. So only the things, only the code parts that are doing some valuable job will be included in this native executable. Also, things like reflection and reflection and serialization, they require configuration with native image, and we will see that in a second. But again, you have more control because those things would need specifically to be configured to be working and included in native image. So again, more control from your side. And also some attack vectors specifically around just-in-time code execution and compilation are not possible in native image just because there is no just-in-time code compilation. So some attack vectors specifically targeting code compilation will just not be sufficient or working in terms of attacks in native image. And now let's talk about powering up our native image applications and what you can do to make them even more powerful. So the first thing I want to recommend for you, if you will be building native image projects, is to use our native build tools. That is our official Maven and Gradle plugins built by our team. So those will help you build and run such native executables, but also they will come with support for JUnit testing out of the box. So you can also test your application in the native image mode, just as you would on the JVM. So if you want to build your first application, my recommendation is that you will include either Maven or Gradle plugin. No difference from my side, but please do use our native build tools. And one of the aspects that those plugins enable is testing such applications. So let me show you how you would test such a native app. Let me just get the right window. Okay, not this one, but this one, I think. Yeah, this is it. Okay, and let me open the right folder. Okay, it's this one. So what I have here is my main application class and also a calculator class that is doing some calculations. And also I have tests in place that are supposed to ensure that my calculator is working properly. So we are just testing that functionality. And if I look at my POM.xml, one thing that I have here is my native Maven plugin coming from GraalVM build tools. So let me build, or rather test this app and see how it works. Okay, should be good. So as you can see, I'm executing a rather short command, right? So I'm just saying Maven pnative test, but under the hood, it's executing quite an extensive native image command, passing some flags, enabling GenUnit support and all of that. But this is something we don't have to worry about because this is being taken care of by the plugins. So we are compiling our app now, and it's a small one, so it should be done soon. So our build is finished. And if we look at this report that is also helpfully printed out for us, we will see that we ran each of our tests in the native image mode, and all of our tests are successful. So this specifically tested my app in the native image mode. But if you want to see what exactly has been produced as the artifacts of this test step, here is our produced artifacts link, and our tests are in the target directory. So let's try just running them in native mode. And if I do this, we see the same result. So our tests are running, and it was actually a native app. So our tests got compiled to native as a part of this test phase as well. Let me go back. I don't know, I still don't see the chat somehow. So if you have some questions, please let me know somehow. Okay, this was testing.
Hey, can you hear me?
Yeah, I can hear you.
Oh, I changed my machine. I think everything is working now. But we got a question. I don't know if you want to answer that. It is what it is JIT. Actually, I think someone asking that thing from Twitch TV. So we are streaming on multiple platforms, and someone asking what it means JIT.
Oh,
Could you?
sorry. Sorry, I'm using some slang. So sorry for that. When I'm saying JIT, I mean just in time, right? So just in time compilation, that is the default execution mode on the JVM, right? So when you run your Java command to run your app, it's being executed just in time. So on the go, that is how JVM typically executes your code. And native image is different from running on a JVM in the way that it executes code ahead of time, so AUT mode, meaning that it will compile and optimize your code ahead of time rather than the JVM, which is executing your code as you go, as you're running your application. So basically, JVM is executing your code on the go as your application runs, and native image is optimizing and compiling your code at the build step. I hope that answers the question.
Amazing, excellent. Actually, Rodolfo also said in the chat, no questions. Your presentation is very clear. Thank you.
Thanks. I don't know why I don't see the chat. Maybe next time I should have like a different StreamYard instance on my phone so I can see it. But thank you for reading the questions. Thank you.
Okay, so please go on.
Yeah, I'm going on. Okay, so we looked at testing some basic application, and some more news that we got recently is the JUnit team announced that they also will have those annotations for testing, like annotations that specifically execute some tests, like classes and methods in GraalVM native image mode. So you can explicitly either enable or disabling certain things to be executed in the native image mode. So this is another thing to note in terms of testing such native applications. And okay, we looked at testing some basic app, but what if we want to test something more advanced? So let's say we want to test against, I don't know, a database, which probably would be the case if we want to run such native applications in production. For that, I think one helpful thing would be to, as I said before, look into the frameworks. All of them offer some kind of testing support, including in the native image mode. And I want to illustrate that point on the Micronaut framework, but the same thing is available, okay, maybe it's not exactly the same. I will not don't quote me on that. But Quarkus also has this Quarkus Dev Services thing that is doing a very similar thing. And I think if you look at Halidon on Spring Boot, they will also have some kind of support for testing in the native image mode. But in this demo and in this talk specifically, I want to use the Micronaut test resources app and project, and I want to give credit to my amazing colleague Cedric Champeau, who worked on this feature and worked on this demo and that I want to show you next. So let me show you testing some more advanced app. And for that, let me go back here, and here is my app. Where is it? So this is kind of a book management app where I have a bunch of books that I can handle in this app with properties such as author, think book ID and so on. And here I have my controller and repository of books. And to test this app, what I have is one is just a simple greeter task saying like confirming that it can say hello world. And the other task that I have is trying to actually put and then read some book from the repository. And here specifically, we are using MySQL. So we would need a MySQL instance that we can test this app against. So let me try and build it. And as it builds, I will talk with you about what it does. So this is my project and it's a Gradle one. So let me test it. Okay, it's starting. And one more thing that it's using. So as it builds, I will also talk with you about what it does. And if you pay attention to this output, which changes very quickly, you can see test containers here. So one of the features that this Micronaut test resources project is using under the hood is test containers. I'm sure that there are people here in the audience who know and love test containers. So if you do, please raise your hand in the chat. Me and my friend Oleg Shalai would be very happy to know that you know and love test containers. Okay, in the meantime, yeah, sorry.
It is amazing. So we can talk to him in the future, maybe to bring some features to those things to the chat. So
yeah, let me know. I can tell Oleg that you are waiting for him to come to the stream as well, and I'm sure he will be happy to talk with you about test containers at any time.
Okay, amazing. Thanks, Alina.
Sure. In the meantime, our demo is finished. And if you look at the output, what we see here is that we got a MySQL container that let us test our app and all this functionality that we have. So putting a book in the database and reading from the database, it all ran successfully. And also our greeter test, the one that said hello, it is also working successfully. So long story short, if you want to test against external dependencies, look at your framework and what it offers. Most likely there will be some nice kind of lightweight and easy to use testing support for testing against external dependencies. So here, as you can see, I did not need to configure anything for MySQL. I did not need to set up any credentials, any configuration. That has been provided to me by the framework and by test containers. Okay, so let me go back to the slides. Okay, it's a pity that I don't see the chat, but let's try doing this. So GraalVM and reflection. How many of you have heard that GraalVM doesn't support reflection?
I've been listening about that. I don't know if it's
I mean, I myself have heard about this, and I'm a GraalVM developer advocate. So I hear this concept from people all the time. So yeah, let me talk about GraalVM and reflection and what's up there. So GraalVM obviously supports reflection, but there are some things to know. So as I said in the beginning, GraalVM is also a proper, normal, full-blown JDK. So you can run the applications on GraalVM as you would on any other JDK. No problem with reflection there whatsoever. Now, in the native image mode, reflection is also supported. But as we said previously, the native image compilation happens under closed role assumption. And that is the way native image is designed. So to compile the application ahead of time before it actually knows what the application does at runtime, it needs to know everything about the application behavior and what are you planning to do with it at the image build time. So more dynamic Java features such as reflection need to be configured because there is no way to figure out what will happen at the image runtime unless you've run the application already. A native image, since it's doing things ahead of time, doesn't have such capability. So such things would need to be configured. But again, there are some good news related to that as well. One is that native image will try to detect some of the reflection calls automatically and will try to figure out those reflection calls for you. So that is one thing to know about GraalVM native image and reflection. That is, native image will automatically try to detect some reflection calls. That is one thing to know. Next thing to know is that also some information about reflection could be coming from your library or framework, and that is, again, a preferred way of having reflection configured. So if you're using some library, if you're using some framework, in ideal case, such configuration will be coming from them, and they will like enable this information to native image, because probably they know best what their library and framework are doing, and it's ideal that they provide this configuration from their side. Now, another thing that can happen is that, let's say you don't have such information available, maybe you aren't using any libraries or frameworks, or maybe they don't provide such information. So one more thing you can do is that native image comes with this included tracing agent that will observe your application behavior and will try to provide this configuration for you, so you don't need to do it manually. So the way you will do it, and we will see it in a second, is that you will run your application with native image agent enabled. It will observe what your application is doing on a JVM, provide such configuration, and then native image can pick up that configuration and build your app with this configuration in mind. And the last thing is that you can build such configuration manually by yourself. We will see the example in a second, but it's just easier if you're using the tracing agent. Only we ask that you make sure after running the tracing agent that the configuration is complete. But so just manually double check, but usually that's quite helpful to produce at least the majority of configurations, so you don't need to do it manually. And let's look at working with reflection in practice. Let me just get another demo. Okay, so it's this one. And let me open the app.
The audience are saying that is very good presentation in the
Oh,
chat.
thank you so much. But that's also like a bit on you, because it's always nice when you have someone to talk to, and the audience is very supportive. So thank you a bit. Thank you a lot for that. So yeah, let me see if we can make the reflection work. This is our application, and what it's doing, this is my main application class. So it is trying to access this message field from this message class that I have over here. And as you can see, it's doing it like, let's say, in a slightly less obvious way, a bit more maybe complicated. And the reason why we are doing it like this, it's because we are trying to confuse and outsmart native image, because if this was written in a more kind of obvious, predictable way, native image could figure out this reflective call on its own. So as I said, automatically. But for the purposes of the demo, to show you working with the configuration, we are doing so in a less maybe obvious way. So this is my application, and let me quickly check my POM.xml. So I have my native image agent enabled. So let me set this to false, save the file, and let me check also my config files. Target native and reflect config. This is empty, looking good. Let me go back to POM.xml. Again, looking good. And let me try and build this app, and then we will see what happens. And let me also skip my tests.
Don't do this, guys. Don't skip your tests.
I have a friend that is doing the exact same, saying the exact same thing, and every time he's in my presentations, he has like a heart attack when I'm typing skip tests. So yeah, please don't do this. This is only for demo purposes. Don't repeat this in real world scenarios.
No, I'm so good.
Yeah, but
you are allowed to do everything that you want, okay, Alina? Don't worry.
Yeah. But the reason also I'm skipping tasks that because I want the application to actually build and not complain to me at the build time. So now that it's built, let me try and run it and see what it does. Okay, so target example app. And we get this reflection not working message. And this is coming from here where we are handling an exception. So let me see if we can fix this app and if we can make this reflection here work. So first thing I will do, I will go back to my build file and I will enable the agent. So we are setting this to true. Okay, this is looking good. And also I have this little script over here just so I wouldn't need to type all of this. So this will run my agent on a JVM and will produce this configuration for me. So one last check, looking at the reflect config, it's empty, looking good, and let me run the agent. This ran, it was quite big, quick, and you can see my configuration almost magically appeared here. It clarified for me, or rather for my native image build, where this message field and message class should come from. And this is the work that the native image agent can do for you, right? So it can like observe what the application is doing and kind of fill this configuration for you. And as you can see, this configuration is not very extensive. So this is something you can do manually. But if your app was bigger, probably that would be quite cumbersome to have to do all this manually. So as I said, ideally, this will be either automatically figured out by native image or coming from library or framework or produced by such tracing agent. So let me build the app again now that we have configuration in place. And I don't know if you paid attention the first time, but even if we are looking at the native image command now, we can see that the native image kind of command build changed. And now it's significantly longer because it's picking up configuration now that the agent is enabled. So those config files are in standard locations, and now native image having access to the agent can pick up those configuration files. Okay, our app is built, and let me try running it again. And now we can actually access this hello native message coming from our message class. Okay, do we have any questions yet?
I have a little question.
Yep.
This kind of process is just to help the compilation, the native compilation, am I right? Just figure out the fields by reflection, and when synthesize the binary, it will put on the same binary just to let the application knows what fields do you want to figure out. Am I right? I don't know if I.
Yeah, so yeah, indeed, this is trying to help native image to have access to this information, because for native image, it's pretty much impossible to know what happens at runtime, right? And by giving it configuration, we kind of help native image see more, because it's happening, like the build process is happening on the closed world ahead of time. So by doing so, we are letting native image native image know what the application will be doing at the runtime. And this way, build an app that is aware of the runtime behavior of your application.
Oh, amazing! Thanks, Alina. Thanks.
Thank you. Okay, let's move on. And okay, maybe this reflection part wasn't so complicated for your own app, but because you probably wrote your app, so you know what is happening there, you have full understanding of it. But what about reflection in third-party libraries? So what if you're using some external library and there is some reflection happening in it, but it's hard for you to understand exactly how to configure that library? So there is something to do about it as well. And let me show you what exactly. So yet another demo.
Hey, Alina, we got
Yep.
two questions.
Let me start the build, because I know that this one will take a while for some reason. So I will start the build and then I will answer the question, if that's okay with you.
Oh, sure.
Let me just so let me super quickly walk you through the app if I can find it. I really need to clean up this machine. Okay, so there's my app, and it's an app that is, okay, this is wrong. So this is my app, and it's trying to put and then read some customer list from the H2 database. So this is basically the whole application, right? Just working with some data. And here is my POM XML. And what I will do here is I will remove this part of config, and we will initiate the build, and then I will talk with you about what exactly was happening there. Okay, where we are should be good. And let me start the build again, skipping tests, and I apologize for it. Okay, so what were the questions? Sorry, I think you said we had some questions.
Sure. What Rodolfo is asking, actually, first of all, let me thank Cedric. He's helping us in the chat. He just
Why I
answer.
don't see the chat? This is so weird.
Yeah.
Okay.
Eric asked. I think he asked something that you can comment at the end of the talk.
Mhm.
It's about the GraalVM movement on the inclusion of OpenGDK
Sure.
build. So we can discuss that at the end of the session. But Rodolfo asked about after native image is compiled, I need JVM environment to run it, or if send it another machine, for example. And the Cedric answer the question that no, you get a native binary which is standalone, no JVM needed. So you can copy it to another machine, and as long as it has same architecture, I think
Yeah.
x86
Yeah,
and so on.
that's an excellent question, and thanks Cedric a lot for helping with the questions. And also, I'm super honored that Cedric is listening to my talk. I did not expect that, so thanks for that. About needing a JVM. No, you don't need the JVM to run a native executable produced by native image, and that is why it is so lightweight and fast, right? Because that's a native app. So after the compilation, it's a native app. It doesn't need a JVM to run, so it can run on its own, and it has all the necessary runtime components, kind of lightweight and slim, included in the file. So it doesn't need a JVM, but it does need to be built on the target platform. And we will talk about that in my slides in a second. So long story short, no, you don't need a JVM, but since those native executables are specific to a platform and architecture, they need to be built on the platform where you are intending to use them, or you can use things like GitHub Actions to build for various platforms. So I hope that answers that, but also I will have this about like needing JVM and cross compilation later on in the slides. In the meantime, our app is compiled, so let's see what it does. So if you recall, we were trying to read and insert some customers from a database. So it's compiled and it's called H2 demo. So let's try running this. Okay, and it crashes, and who doesn't love it when live demos crash, right? And this one specifically says that it cannot figure out how to work with H2. Luckily, this one is easy to fix, so I can just go back here and put back this config file, and let me restart the build, and I will tell you what I did there. Okay, configuration is a place, the file is saved. Oh, sorry. Yeah, building. So what is happening here in my POM.xml, I have again my native build tools. And one part of the config that I have here is I'm saying enable access to the metadata repository. And let me show what is this repo. So when I go here, so this repo is introduced by our team and currently maintained and built out by our team and community, including people from the Micronaut team, from the Spring Boot team, Red Hat, a lot of people in the ecosystem. And this repo is a centralized place where users or library maintainers can contribute and share and then reuse configuration for native image. So as we saw in some cases, for example, reflection, native image might require some configuration, and there are multiple ways, as we discussed, where this configuration could be coming from. Ideally, it will be coming from your library and framework. But if it's not available there, what is another great thing that you can do is that you can pull this configuration from this repository. So we thought that probably a lot of people are trying to solve the same challenge. So solve, let's say, configuration for reflection for library X. And what if we have centralized place where people can pull this from rather than trying to solve this every single time? So if you look at this repo inside the metadata folder, you will see here configuration available for a lot of different libraries and technologies. So you see here H2 that I'm trying to use in my app. You see things like, I don't know, Hazelcast. What else is there? Let me see. there were quite a few databases, I think, here. So you can see Postgres, you can see MariaDB, MySQL, all kinds of things. So this is where you can pull this metadata from. And the best part is if you're using our native build tools, so this is the reason why I recommended our Maven and Gradle plugins. They are integrated with this repository. So I do not need to specify that I want to use something specific from this repository or from this library. I'm just enabling access to this repo. And now that I rebuild my app, let me see if it works. Okay, and now it successfully works. So it can insert and read those customers from the database. And all I changed here was just enabled access to this repo. So I wasn't configuring any kind of access or configuration for H2. So I think this is pretty cool. Please give this repo, check it out and contribute as well. We also have a blog post about how you can contribute to this repo. It's pretty simple, but even using our tracing agent, you can easily figure out configuration and copy it and contribute to this repo. So please help us build out this repo that everyone can use to make more and more libraries easy to use with native image. With that, let me go back to my slides unless we have some more questions.
So, Lina, I think you shared me those links to share
Oh,
with each other.
absolutely. Will do.
Great. I got another question, but I don't know if you
Sure.
want to end up and go ahead with your presentation and
I think we can
tackle.
stop for now since I stopped anyway. So we can, yeah, what's the question?
Yeah, George Tavares asked it down here. I think it's about the JUnit integration test that you did previously. Do we have two native executables? Am I right? One to one to run the real application without the test code, and one with the tests to JUnit test environment. Am I right? It's true.
Okay, so let me look at the question closer. Also, thank you for pulling them up so I can see them. One to run the real application without the test code, and one with a test to JUnit test environment. So I don't know if that helps, but when I was running my tests before, let me super quickly go back there. So when I was running my tests before, it was kind of a separate native executable with just tests on their own. Let me bring this up if this helps. So it was in target native tests. So yeah, here tests were pretty much its own native executable. And one more thing about testing on native image that I probably should have mentioned in the beginning is that also we get this question a lot, like should I test every single change in the native image mode as well to ensure that it works correctly in the native image mode too? And the answer to that is that we expect the application to behave and run tests in native image mode just as it does on the JVM. So normally you can develop and test your application on the JVM, and you don't need to do this native image compilation step and test in native image mode as well on every single minor change, especially if that change is more around your business logic. So this can be as more like once in a while step or when you're making some bigger changes. But in general, it is expected that your application behaves the same way on a JVM as it does in the native. So you don't need to do this on every single minor change. This can be as a more or less final step in the development of a particular feature or a particular component. And in terms of executables, so here we can see that a separate executable was just tests. So I hope that answers your question.
Yeah, I think that I and I did a wrong thing. So what I mean is when we execute the test native tests, actually we are creating two native binaries. One with the tests that execute your native code, or it's both ones are separated. Vincent. So your test.
So I would say as separated, but
Oh,
I wouldn't lie to be honest. So I don't want to lie to be honest. Like my bet is that they are separated, but also if you can ping me afterwards in Twitter DM, that would be very helpful.
okay, great. Thanks a lot.
Thank you. And let me go back to the slides. So here we talked about handling reflection in third-party libraries, and I want to say a few words about optimizing performance. Because we all know and love JVM for how good it is at peak throughput, right? So how good it optimizes our applications for peak performance. And indeed, JVM is a great system and platform for that because executing your application dynamically, so just in time, as we discussed before, and also having profile information available to us and having this opportunity to constantly adapt to your application behavior, get profiling feedback, if needed, de-optimize and compile again. All those things mean that your applications will run with a really great performance on the JVM. So native image, it executes applications a bit differently. So as you can see here on this example workload, native image starts really fast in the very beginning, but then over time, as the JVM warms up, it also gets great peak performance. But there is a way to also achieve great peak performance with native image as well, and that is to use something called profile guided optimizations. So as we talked, native image optimizes and compiles your code at the image build step. So it needs to know everything there is to know about your application when it's building it ahead of time. But how can it know about how your application performs at the image runtime if it's doing so ahead of time, right? And there is a way, again, to handle this. So one thing you can do is you can collect profile information. So the information about the application, what exactly it does, which methods are often called, which loops are often executed, and so on. And you can use this profile information by giving it to the native image. And then at the image build step, it will build a native executable aware of those profiles. So aware of your application runtime behavior. And this way it can achieve, in addition to great startup time and low resources usage, it can also achieve really great peak performance by having this profile information available. So if you want to make sure that your native image application performs great in terms of peak throughput, please check out profile guide optimizations. This will really help you. So this is one thing. And another thing to know about application performance is memory management in native image. So we also get this question a lot. What kind of GC options are available in native image? And those are the following. By default, there is serial GC. So that's a default option in native image. You can also get G1 GC, and that is something available in GraalVM Enterprise. So GraalVM does come in two editions, that is Community and Enterprise. And Enterprise requires a commercial license, but also it's available for development, testing, or it's available on Oracle Cloud. So I absolutely do encourage you to check out Enterprise as well for access to all those features. And then the last feature in terms of memory management is that if you do not need to perform basically any GCs at all, you can also use Epsilon GC. So those are the memory management options that you get with native image. And speaking more about like using your native image application in production and things you need to be aware of or things that you would rather want to know for actually working with it in production. Another thing is that to monitor your application performance, you also have GFR support available in native image. And I do need to say that this is more of a work in progress. We are constantly working on this. We keep building this out together with the community. But this is already working in native image. You can monitor quite a few events. So if you want to use JFR, you do get such opportunity in the native image as well. And again, in terms of monitoring, we are also working on adding JMX support. So as you can see, this is a part of our community roadmap on GitHub. Again, this is a contribution, in this case, from Red Hat. So we are working on making more monitoring features available in native image as well. And talking about the last part of this kind of cloud story, and the last thing you probably want to have in the cloud, but also in resources constrained environments, and that is the compact packaging. So probably if you are deploying your application to the cloud, you want to make sure that it's also as small as possible, just because it's better for deployment, but also so you can deploy and redeploy more frequently or as you need. And for that, what native image means is that, as we also were answering question, right? So all the relevant JVM runtime components that native image application needs are already included in this native executable itself. And also we eliminate all the code that you are not using. So if there is something in your app that you don't actually need, that is never executed, it will not be in the image. That's why it's more compact. And yeah, also by having your app compiled as a native image executable, they do not have the same Java runtime shared between them as you would when you run the application on a JIT, but also they can be patched as you would need, let's say, individually. And in terms of compact packaging and making sure that your native executable is as small as possible, if you specifically care about packaging size, one more thing you can use is UPX. So this is a tool that will allow you to compress native applications. The same applies to GraalVM Native Image executables. And here you can see, for example, that you can take your application size, let's say from 66 megabytes to just 17, which is, I think, quite awesome. The only thing to know about this that this is a good thing if you need smaller packaging size, but as many things in life and software engineering, it's a bit of a trade-off. So if you're using very aggressive compressing algorithms, this can have an impact on runtime behavior of your application. So be aware of that. But in general, if you care about packaging size and it's a major, I don't know, factor for you, using something like UPX can really help to take this packaging size even more down. And talking more about deployments, another thing you can do with native image is to build fully static or mostly static native images. So fully static would be fully independent, working on its own, and then mostly static will be linked against everything except for libc. And this is something that you can use in the pretty minimal containers, so you can have very small container images. And again, to illustrate that thought about how low you can go with the container image size with native image, and specifically in various modes of it, is that here in red, you can see bars for running on a JVM, and then in green, running your app as native image with various deployment options. And if you want to absolutely minimize this size, you can do from scratch container with a fully static native executable, and you can go to below 20 megabytes. I think this was for a basic like Hello World kind of application. Or if you want, you can compress it even further to go to something around 5 megabytes if you compress it. So this is quite good. And if you're curious in this topic, we did a whole big talk about this at DevOps Belgium last year, I think. And you can find it on Google, but also I think we can link it in the notes. So the name for the talk you can see here on the slides. It's a 1.5 megabyte Java container app by my colleague Sean Smith. So if you want to learn more about this, this talk is a really good source for it. Okay, and I think this is all sounding good, maybe a bit too good so far. So what is the catch? Because I can expect that question to pop up. So one thing we talked about reflection, right? And how in some cases it might need some configuration. Sorry, I skipped my slide. So yes, reflection might need a configuration, but there is a number of ways where this configuration can come from. It can come from your library, from your framework, from the tracing agent, and then in the last case, it can come from you. But it's just the nature of native image, right? That it's doing everything at the image build time under closed role assumptions. So more dynamic Java features such as reflection would need to be configured to work within those limitations. Now, another thing is the required build time step. And obviously all apps have a build step of some sort. But then with native image, things to specifically have in mind is that this build time, depending on how big your app is, can take some time and some resources. So be aware of that a bigger app can take more time to build than, let's say, a smaller app, right? So you might need some extra time and extra resources for your application to build. Though lately we've been working on reducing those resource demands for native image, and now even bigger apps are can be built with around, I would say, 2 megabytes of memory. So even in resources, even in environments such as GitHub Actions, you have sufficient resources to build even bigger native image applications. That is good news, but be aware that it is needed time and resources to build bigger native image apps. Another thing is that, yeah, you need a good machine with the same target architecture and operating system where you want to run your application. But this is something you can, again, solve by using GitHub Actions, where you can build for various platforms and then then distribute those produced native executables. And as a recommendation, you can usually develop in the JIT mode, so on a JVM, and then use this native compilation as more or less the last step in your development process, so before the final deployment. And yes, as I said, if you want, in addition to startup time and memory usage, if you want also great peak performance, please use profile guided optimizations for the best peak performance. That is that. And how we're doing? Oh, I've been talking for over an hour. Let me see if I can speed up a bit. I wanted to talk with you about also what's new in GraalVM. IntelliJ IDEA team announced this a while ago that debugging of native image applications is coming to IntelliJ. So this was available in the preview build with, I think, this specific plugin that you need to install additionally in IntelliJ. But this is great news, and I think we are all looking forward to having full debugging capabilities of native executables in IntelliJ. Now, we're also working on monitoring features in GraalVM Native Image. So I talked about JFR, I talked about JMX coming in one of the next releases. And also, as of the last release, we enabled JVM Stat Native Image. So now you can also monitor native image applications in things like Visual VM and track their performance there. So this is great news. And also we have JDK 19 builds available as of, I think, the last release probably, right? So now you can benefit from all the great features that landed in Java between 17 and 19. One thing you can do is you can take this simple web server that is available, I think, since Java 18 and compile it to native as a normal Java app, right? So you can compile it to native and it will become even faster as it is already. And another thing you can use is that since in JDK 19, we also have virtual threads from Project Loom, you can use those in native mode as well. And I want to illustrate that thought with a demo again. Only for that, I also want to give a credit to the author of the original Java app. So I will show you a game of life implemented in Java running on native image using virtual threads from Project Loom. And this is the author of the original Java implementation that we then compiled to native. So let me run this app. I have it over here. And yeah. So this is running Game of Life, and each cell here that we can see is its own process, and they communicate with each other using channels. As you can see right now, it's using, I think, over 2K virtual threads, right? And each cell is either alive or dead, depending on the state of its neighbors. So it's a kind of computation-heavy app that is constantly doing those calculations to figure out the state of each cell. There is a lot of computation happening here behind the scenes, and this is leveraging virtual threads. So you can build such app and in the native image mode as well. One thing to know to add here is that with this virtual threads available in native image, we now also have a notion of preview features in native image. So if you want to run this app or any other app leveraging virtual threads in native image, you would need just to pass one more flag either in command line or in your build file, that is enable preview. But you can totally build something like this. Just grab our JDK 19 builds and you can use virtual threads and all the latest Java features with GraalVM as well. So let me stop this one and let me go back to the slides. And yes, we have community roadmap on GitHub. Let me see if I can super quickly open it. So yeah, I have it actually here. So as an open source project, we have community roadmap on GitHub. So you can see the things that we are working on at the moment, what is coming in the future, and it's scheduled to land in the next release. And what is in the future hasn't been scheduled yet, but things that we are working on as well and will land in one of the upcoming releases. So for example, in this release that we had some time ago in October 20.3, we now have JDK 19 builds available. We have virtual threads. We reworked quite a bit the third-party API in native image, added a number of other things. And then in the next release in 23.0, we can expect JDK 20 builds. We are waiting for ZGC to become available on Hotspot VM, and we are working on some other things. So if you want to check this out, this is linked from our GitHub repo, and you can see what the features we are working on together with the community and what is coming up in the next releases of GraalVM. That was that. In terms of what is next specifically for native image, so we are working to simplify configuration and compatibility so you can use more libraries in the native image mode as well. We are working on peak performance and GC improvements. We are working with all the framework teams so you can use all the GraalVM native image features with whatever the framework is of your choice. And we are also working with IDE, so it's easier for you to build such native image applications in the IDE of your choice. And another recent update is that we now also have this page on the GraalVM org website where you can see libraries and frameworks that are tested to be working with native image out of the box. Because this is another question that we get a lot is how do I know if I'm planning to use library X? So how do I know whether this works with native image or not? Now you can go to our website and find this list. Here, there are libraries that are either tested by their maintainers and proven to be working with native image or tested by our team in community in this reachability repo. So I think this is very helpful if you want to figure out if a certain library will work in the native image mode. Okay, and to get started with GraalVM and native image in particular, here are the ways. You can either get the latest GraalVM version with this one-line command, or if you're using SDK man, which again we all know and love, you can easily install GraalVM with SDK man as well. So to wrap this up, why you could be interested in GraalVM and native image in particular, it's because such native applications would start fast, would use very little resources, will have additional security layer to them, and will also have smaller packaging. And that was it. We can go back to questions. If you would rather ask them directly, here is my Twitter handle. And I do remember about that question about OpenJDK. So yeah, this was announced at Java 1 this year that Java part of the GraalVM project, namely the JIT compiler and native image, will become part of OpenJDK. So I think this is a great news because more people will be able to use those components if they want to use the OpenJDK distribution of JDK. This is happening. We are actively working on it. If you've been following our announcements, you might have also seen that we made a proposal for a project called Galahad, where those changes will be implemented. So yes, a lot of changes coming. Wait for more announcements. And this is one thing. And another thing that could be probably relevant for you if you're a GraalVM user is that we are also aligning our release schedule with the one of the OpenJDK. So their release schedule is that every 6 months there is a feature release. And we are also working on aligning that as well because we used to release GraalVM every 3 months. But to be better aligned, we will also have releases of new features every 6 months as well. So that was about the OpenJDK parts. And do we have any more questions?
So,
Yeah, sorry for speaking so long. I did not plan to speak for like over an hour.
well, that's okay. It's amazing. Actually, audience is saying that was amazing presentation. George Tavares is also clapping his hand about this presentation. I think he had been talking to you in behind the scenes on Twitter. I think so. And also, I got another gratitudes. For example, Rodolfo also said thank you, Alina. Oh, Cedric is there in chat as well. Cedric said
And
hi,
I
Alina.
stopped sharing so I can finally see the chat as well because I can access StreamYard. So this is good news. Finally, I can see everything that people have been saying.
We got a little question, but from Mustasa Iqbal actually, but I don't know what it means about using Docker images. So
yeah, you can use You can use GraalVM with Docker, absolutely. So you can deploy on certain Docker images, or even you can build on Docker if that is your preference as well. So yeah, absolutely.
Just correct me. When we are building a native application, it's a self-contained one, or it's related to link to some libraries on
Yeah,
this.
so
So
you get options. So it's self-contained in a way that it doesn't require JVM to run, right? But then again, you get options. So you can build it fully static, like fully self-contained, or you can do mostly static. So you wouldn't link against libc. So maybe you want libc to be provided by your OS layer. So again, you get options. But if you want, you can build a fully self-contained app as well.
oh, great. I have another question. I think it's a little polemic one, but
Go ahead.
um, I see most of Java developers saying that, oh, if your application lives a long time, have a long time living, is preferred to use JIT and the Java pattern application instead of to use native one because of the JIT improvements that could be bring to the application. What is your opinion about that? We could just okay, let's getting start to use native ones, or we need to. Of course, we need to pay attention, and it's depends of context. But I don't know what is your opinion about that.
Yeah, thank you for question, and thank you for like question it so precisely, because sometimes people would just ask me like, when should I use GraalVM and when should I use JDK? Like GraalVM is also a JDK, so it's not exactly opposite things. But in my opinion, like you should always use GraalVM. Now the other question is which part of GraalVM, right? Because GraalVM also has a JIT compiler. I did not stop on this in this talk because we were talking about native image here. But the thing is, GraalVM is a full-blown JDK distribution, but it does have its own highly optimizing compiler. So if you're aware of the Hotspot VM, there are a few compilers, and the top tier highly optimizing compiler is C2. So what we are doing with GraalVM is that we have the exact same Hotspot VM as you would in any other JDK distribution, but we are replacing that top tier compiler with our own compiler, the Graal compiler. So you can execute apps on GraalVM as you would on any other JDK distribution. So you can run on JVM, on GraalVM as well. So my answer is always run on GraalVM, but you can choose like either on JVM or in native image mode, depending on what is your preference. So for a longer running app, it could be the case that GraalVM JIT could be a better option in terms of peak performance than native image. But we are getting there. We are actively working on native image improvements. So even if you saw our, I think it was 21.3 release blog post, we got really close to performing on par with running in JIT. So we are working to make sure that in native image mode, you get all the aspects of performance maximized. But my general recommendation is that every application is different and is doing a different thing, having different dependencies, written differently. So probably ideally you compare. So take your app, try running it in GraalVM JIT and in GraalVM Native Image, and then decide what works best for you.
Oh, great, amazing, great answer.
Thank you.
Yeah, yeah, because I saw that serverless world focus on native ones instead of to interpretation programs, because I think the startup is better than another kind of
It
situation.
is, but let me also tell you my favorite story about like real life native image like usage in production. So if you know Alibaba, they have a huge, I don't know, marketplace or how you call it, and they actually run it on native image. And as you can imagine, they are running very long processes, very huge apps for a very long time under very huge load. And they're using native image under such huge load, and they're reporting the results that it's performing great, handling great loads. They're very happy about the performance. So even for such longer running apps, native image can also be a viable option. It's just, I would do recommend that you test on your own app and then choose which part of GraalVM you want to use.
Oh, amazing. Also, I know that your presentations are focused on the Java world, am I right? So, but I know that we can integrate with another language as well. We're using GraalVM. For example, I want to call PHP. Oh, sorry, PHP. Oh,
I mean, you can
I
even use PHP. It's not coming from our team, but that exists a community implementation of PHP on GraalVM as well. So if you want to build such an esoteric app and called, PHP from Java, it is technically possible.
Yeah, no, I did a mistake. Actually,
No, no, no.
I'd like
I'm just
to
kidding. I
next
know.
Python or another kind of language, JavaScript, for example, and then using a kind of polyglot programming. I know that we can do this with GraalVM. Maybe in the future we can prepare some material, some content about that. It's very interesting to see that thing. It's very near to polyglot persistence, I think, but it's more near to logic and the developer stuff. So, but also I'm very glad to having you, Alina. You are so kind. I'm very happy to having you. I'd like to thank audience to be here with us, just asking and participating our talk. And feel free to join us in the future. Okay, you'll always be welcome. Okay, in
And I
our
hope that sometime I can join you in person. So hopefully that is possible at some point. I would absolutely love to come and do a meetup in person as well.
yeah. Eric said amazing presentation.
Thank you.
Okay. So, Alina will give me the links. I will type on Twitter, on our Discord. You guys, audience, to be able to reach out the GitHub repositories and stars on there because it's very nice to see this kind of code. So that's it. I think that's all. Alina, if you want to say something more, also let me thank Cedric. Cedric, I'm spelling well his name. Cedric, am I right? So,
Cedric, yes. And I will thank him afterwards as well because, yeah, as I said, huge honor to have Cedric in the audience. So, and thanks for helping with the questions.
and
And thanks
also
to you.
invite him.
Yeah,
I'd like to invite him to be here speaking as well. But
I'm
that's
sure he
okay.
would be back. He would be happy to speak. And let me show off my Portuguese knowledge and say obrigada for having me here at your community. I'm very happy to be here. Very honored to speak here.
Okay, thanks so much. And that's it, guys. So Cedric Cedric send the claps. Oh, Cedric, thanks a lot. Thanks for supporting. So that's it, guys. So I'm delighted to everyone and see you in the next time. Okay, bye bye, everyone. Bye
Thank you
bye.
so much. Bye.